Hello, my name is Kristina, and in this video, I will show you how Gideon could be useful to a parasitologist with a particular interest in rodent-borne infectious diseases. Let's get started. So imagine you're a parasitologist who also teaches in the university. You might want to formulate good research questions or perhaps help your students formulate good research questions. So the first thing that I'm going to do, I'm going to access this fingerprint search for diseases in Gideon and select reservoir rodent. And this will help me filter down all the infectious diseases down to the list of 91 that are rodent-borne. Perhaps I want to find out more about all the rodent-borne infectious diseases in India specifically. So we have narrowed down the list to just 50 now. And out of those, I'm only interested in parasitic ones. So now we have a list of 17. And among those, I might be interested in toxoplasmosis. So I'm going to hit this compare button and add it to my comparison table for later inspection. I might also be interested in bacterial ones. So out of bacterial ones, maybe I want to dig more into leptospirosis. Okay, and now finally, I would just like to see some mosquito-borne diseases that are parasitic in nature, and malaria is one very famous example. So now what I could do, I could download this PDF, I could share it with a friend straight from the interface, or I could go ahead and compare those diseases side by side. Gideon is the only tool in the world that allows you to do this. And here we have a comparison table of toxoplasmosis, leptospirosis, and malaria. I can now sort by clinical findings and how they manifest in humans, and we can see how these diseases are different or how they are similar. And we also have these lovely clinical summaries down here, which we can now share along with the whole comparison table. But what else we can do? We can have a look at the fingerprint comparison. So we can have a look at how they are different by agent, by reservoir, vector, and vehicle. And this could be a very good teaching tool. Now, suppose I want to have a look into one of these diseases. I'm going to go into malaria. This is the disease page. And the first thing that Gideon is going to do is inform us of where this disease is endemic and where it is chloroquine resistant. As I scroll down, you can see that we have a summary of agent, reservoir, vector, and vehicle, incubation period, diagnostic tests, typical adult and pediatric therapies, any vaccines that are available for this disease. Unfortunately, we do now have 2 malaria vaccines, any clinical hints, etymology, and so on. We also have an extensive images gallery for each disease. Down below, we will find clinical findings section exploring all the possible manifestations of the disease along with robust referencing and even by species, how the disease is different when it's caused by different species. So for instance, Plasmodium vivax is known to cause cerebral malaria. And in here, we can find some lovely references to back up that research. Okay. Let's go to the top and see what else Gideon has in store for malaria. Outbreaks map. Now, we don't collect this data for no reason. We want to visualize this. We want to provide data analysis. And so in here we can see malaria outbreaks map going back to 1866. Now, perhaps that's too wide of a range for us to research at the moment. And I'm going to narrow it down to just the last 3 years. Okay, and here we have an endemicity legend where we identify where malaria is endemic and chloroquine resistant, where there's no chloroquine resistance, but the disease is endemic, and so on. And for instance, we can see that it is quite endemic in India, and there have been some big outbreaks recently. Okay. Now, what I could do from here, I could list all the outbreaks like so, sort them by number of cases, by year, by country if I like. I can click on a particular country and go into the note. So, for instance, malaria in India, we will have some time and place notes, seroprevalence surveys, what we know about infecting species, graphs by infecting species, and many, many more data points. But why dig through graphs in a country note when we can visualize it very nicely and easily with our graphs tool? Let's add malaria in here, and let's select India. Okay, and I will also select cases. So now I'm looking at all the graphs out of 49,000 that Gideon maintains, and perhaps I want to compare different regions. So perhaps I want to compare Haryana with Kerala, nice and exotic place. Let's compare those two and see how malaria cases are different in each place. And I'm going to hit generate the chart, and in a couple of seconds we have this lovely graph here, which we can convert into data table if we like, and see those cases by numbers like so. We can also download this and use it in our presentations, lectures, and so on. Let me clear the table real quick, and now I will want to compare malaria between countries. So perhaps I want to compare India, Pakistan, and Bangladesh. Okay, and in this case, to compare apples to apples, we need to compare the rates. So I'm going to compare malaria cases, rates per 100,000 in Bangladesh, India, and Pakistan. I'm going to hit generate the chart, and here we have this lovely graph illustrating, well, really telling the story. And we can see that Pakistan has a much higher prevalence of malaria than India and Bangladesh when resolved by rates per 100,000. Now you might be wondering, what does this dot mean? This means that we have the data for 2022 and we have data for 2020, but we haven't got the data for 2021. So instead of guessing and connecting the dots, we leave these separated until we get more data. Okay. Right, let's see what else we can do. So if we are teaching and say I'm a parasitologist with an interest in rodent-borne diseases, I might work in a laboratory as well, or at least I might be educated on how to do that. Now, suppose I'm a teacher and I want to go into this decision tree. And I want to identify a particular pathogen. Now, what microbiology teachers do, they sometimes use what's called dichotomous keys to teach their students the process of identifying a pathogen. They can take a lot of time to produce, but in Gideon, you can produce one in just a few seconds. So I'm going to show you how. For example, first we want to identify whether pathogen is gram-positive or gram-negative. We know we are dealing with a bacterium. Let's say the student is having difficulty identifying whether this is a gram-positive or gram-negative. So we can easily skip this step. And then we're going to look at the shape of the pathogen. In this case, I'm going to select spirochete, and I'm not quite sure whether it's curved bacilli or spirochete, so I'm going to select both. And then I'm going to detect that the pathogen is actually aerobe. What does this mean? That means that it can only grow in the presence of air. And here we have a very strong differential just by clicking those few steps. Gideon has collected a lot of data on the phenotypic characteristics and how common they are in each pathogen, and it is able to do Bayesian analysis in the background of the back of that. And in here we can see that we have detected leptospira pathogen. It's 99% likely to be this particular pathogen. So now we can click on the pathogen itself, go into the pathogen page, look at the summary, ecology, drug susceptibility of this particular pathogen over here. We can see there are 30 antibiotics that are very effective against this. Perhaps I want to add some more, and I want to see, well, will there be drugs effective against Vibrio cholerae and Leptospira interrogans? And indeed there are. And I can continue exploring this pathogen page, look at the images gallery, the phenotype, and so on. Just like we compare diseases, we can also compare pathogens side by side. So I'm going to hit this plus button, which you will find all across the interface, and add Leptospira SPP to the comparison table. Now, perhaps I want to compare it to something like Vibrio cholerae. Let me add that in. And now we can see how these pathogens are different from one another. So this slider right here, it says show only distinguishing characteristics. But we could compare the entire phenotype. We could compare them side by side, print this table off, and use it for our purposes, or just email it to the class from here or to our peers and colleagues that we might be working with.